Hello, and thanks for looking at this video. This is just a little introduction to the cognitive acceleration through science education assessment tasks. They're known as science reasoning tasks, and they're all based on the work of Jean Piaget. We're going to do task number 2, which is on volume and heaviness, and I would do this one when the children are in later years in primary school and the early years in secondary school. And usually I've done this as a pre-test, and task 3, which is usually done as a post-test, will be in another video. Now, Jean Piaget and Barbara Inhelder published The Child's Construction of Quantities, 1974, and that's what this task is based on. Okay, you're going to need some equipment, or you can just follow the video and various questions as they happen. Okay, usually I'll go through the demonstration of the task for each question. Then, if you pause the video and allow the children to complete the question, that's the way we're going to do it there. So, good luck, and here we go. This is the first question of the task 2, science reasoning task, for the case activities. What we need is a cylinder, a 100 ml cylinder, and a 250 ml beaker. And I'll just adjust that so you can see both. Okay. And what we do is, A is in the question sheet, A is the cylinder, and X is the beaker. Okay. And here I have a jug of water. Okay. And I fill A, meaning I'll fill it up to 100, measure that properly. I could fill it all the way to the top, of course. Okay, so there's A filled, okay, to 100, and now I put it into the beaker. Okay. Refill A up to the 100 again. Okay, and there they are alongside each other. There's the level in A, and there's the level in X. Okay, and the question number 1 is, A has more, less, or the same amount of water compared with X. And this is A, and this is X. Now, question number 2, okay, concerns 4 cylinders. We have the 100 from before, we have a 250, we have a 500, and we have a 1000 ml, or a 1 litre. Okay. Okay. Now we have 100 mils in here. Okay. What we do is we pour the 100 mils into what we call D. That's there. And we 100 mils again. And we pour that into C. And 100 mils again. B, and 100 mils. And into A again. So now, see, can you see? There's A, there's B, there's C, and there's D. So the level in A is here, the level in B is there, the level in C is there, and the level in D is there. And what the question is, do these cylinders all have the same amount of water? Yes or no? And if you answered no, write down which has the most. Is it A, B, C, or D? Question number 3. Over here I've got a hot plate and I've got 4 kernels of popcorn and they're all starting to pop. That's my last one. There we go. That's it. Okay. Now what I'm going to do is just show you. Okay. I've just made some popcorn. There's the 4 popcorn. Popped corn. Okay. Now here's what I made them from. I made them from these kernels. Okay, and I've got 4 kernels. Now inside the kernel. So I've got 4 popped corn and 4 kernels. And the question is, the popcorns, do they have less, more, or the same amount of maize compared with the grains? That's A, 3A, and 3B. Do you think the popcorns weigh more, less, or the same compared to the grains? So A is about which has the most maize, is the popcorns or the grains, and B is which weighs more, is the popcorns or the grains. Question number 4, and what I've got here is a large plasticine block, okay, and it's a certain size, okay. Besides the plasticine block, I also have all of these wooden blocks, okay. These are little small wooden blocks, okay, and I'm going to put the 2 together and do something with those. Okay, so if I take 5 of the little wooden blocks and I can stack them one on top of the other, okay, and you will see that 5 blocks stacked on top of the other are level with that block, plasticine block, okay. So there's 5 blocks worth up the side. Now, question: how thick are these little blocks? They're all 1 centimeter, okay. And then I have the remainder of them, and the remainder of them are 12 of those little blocks, okay. Just to show you there, you can see I've got 3 rows of 4. 3 rows of 4, that makes 12, okay. Now, the question is, okay, if I can put 12 of them on top, if they fit 12 of these blocks on top and 5 down the side, what is the volume of the plasticine block in cubic centimeters? Okay, and show your working. So if I can put the 12 blocks without any problem up there, and that fits the top of that block, and there's 5 down the side. What is the volume of the block? Here I have the plasticine block. I've changed it slightly just so I can fit it into this cylinder. The cylinder is filled with water and it's sitting in a trough. Okay, so here it is. Here's the block. Okay, and it's the same block, so it has the same dimensions and all. And what do you think will happen if I put the block into there? You give them that. See, it's water right at the top. Okay, it'll overflow. The question is, how much water will spill over when the plasticine is all under the water? Okay. Question 6. It's the same cylinder, the same block, but there are 3 points. We have A is at the top, B is halfway, and C is at the bottom. Okay. Now, when I put the block into the top, okay, maybe you'll see water overflowing. Okay. But if I lowered it down to B, which I'm indicating here with my finger, if I lowered it down to B, would there be more, less, or just the same amount of water spilling over into the trough? Would there be more, less, or the same amount of water spilling over into the trough? Okay. And if I lowered it to C, which is at the bottom, down there, if I lowered it into C, the question is, would it be less, more, or the same amount of water spilling over? Question 7. Okay, in question 7, we are going to take out some of the water. Okay, and just until it's much less, just to top it up to about 500. Okay, so now there's a cylinder with 500 mils in it. Okay, and if I lower the plasticine until it's just under the surface, I'm not going to do it, but if I lower it till it's just under the surface, so you have 500 there, and if I lower it down onto the surface, what would the new volume reading be? Now, question 8. Now, if I take the plasticine and I make it into a ball, a round ball, okay, instead of a block, okay, and I was to put it into the cylinder, would the level be the same, higher, or lower? Question 9. If I take the plasticine and instead I make it into a long cylinder, sort of sausage shape, okay, will that, and lower it into the water, would that make the level the same, higher, or lower? Question 10 concerns a metal block. Let's just assume that the metal block has the same volume as the plasticine block, and I lower the metal block now. Okay, the metal block is going to have, but if I was to lower that into the water, would the level be more, less, or the same? And given that it's a metal block, and why do you think so? I've got a flat piece of plasticine. It's a disc, black disc, okay, made of plasticine. And the question is would this float if I put it into the water? Will this flat piece float or sink? Okay, so it's this size. Now, next question is B, 11B. If I torn it in half, okay, and Make it into a disc again. And will that piece float if I put it into the water? And then question C is, if I take this small piece of the plasticine, okay, and I put that in the water, will that piece float or sink? Specifically, will it float? Yes or no? Will the piece it came from, will that float? Yes or no? Or with the original flat piece, the larger piece, will it float or sink? Now, finally, the last three questions on the assessment, okay? And it concerns these boxes. The top box is 10 by 10 by 10, and it says it's full of dry cleaning fluid and it weighs 1,500 grams. Another box is twice as tall and it's filled with water, but it weighs 2,000 grams. So would the box with dry cleaning fluid, would it float or sink in water, is the question. And how did you work out your answer? Now, B then, you take this box that had dry cleaning fluid and you empty it and you fill it with alcohol, and it now only weighs 850 grams. Will it float or sink in water? And how did you work out your answer? So, start again. We have a box 10 by 10 by 10. It weighs 1,500 grams when it's got dry cleaning fluid in it. Another box is filled with water. It's twice as tall and it weighs 2,000 grams. Would the box with dry cleaning fluid float or sink in water? And how did you work out your answer? Then you take the smaller box, you empty it, and you put alcohol in it, and it weighs 850 grams. Now will it float or sink in water? And how did you work out your answer? That's question 12. Question 13 shows Archimedes working out the problem with the crowns in his bath. How do you think Archimedes measured the old and the new crowns' volumes, comparing them using a measuring cylinder? Okay. How could he have done that? And then B, Archimedes weighed the two crowns and he found that the new bigger crown weighed more than the old one. Nevertheless, he said the new crown had some lighter metal in it. How do you think he worked it out? And finally, in question 14, we have two blocks, A and B, and they're both made of brass, and the same brass. A weighs 60 grams, and its volume is 15 centimeters cubed, and B weighs 160 grams. But what do you think its volume is? And then how did you work out your answer? So that's the 14 questions of the task number 2 of the science reasoning task designed by Piaget and Inhelder, and this was used for the concepts in maths and science at Chelsea College, University of London in the 1970s.